Mazda makes great cars, excellent engines, outstanding driving dynamics, impressive build quality. But even great manufacturers make mistakes. And Mazda has made some decisions over the years that are genuinely baffling. Features that sound impressive in the brochure, but cause real problems in the real world. Technology that was rushed to market before it was ready. Design choices that prioritize aesthetics over accessibility and repairability. Convenience features that create inconvenience when they fail. And they do fail. I've been working on Mazdas for years, and I've seen the same pattern repeatedly. A customer comes in with a problem. I diagnose it, and when I explain what caused it, they're always surprised. Because the cause is usually a feature they loved when they bought the car, a feature that was sold to them as an advantage. That's now costing them hundreds or thousands of dollars to repair. Today, I'm pulling back the curtain on the Mazda features that actually hurt reliability and lifespan. Not because I don't like Mazda, because I do. And I want you to get the most out of your car, knowing which features to be cautious about, how to use them correctly, and what to watch for is how you avoid expensive surprises. Let's get into it. Feature number 1, the e-Skyactiv X combustion system. Let's start with one of Mazda's most ambitious recent technologies. The e-Skyactiv X engine uses SPCCI, spark-controlled compression ignition. This technology alternates between gasoline and diesel-like compression ignition, depending on operating conditions. In theory, it's revolutionary. Better efficiency, cleaner combustion. In practice, it's one of the most complex combustion systems ever put in a mainstream production car. SPCCI requires incredibly precise control of combustion chamber conditions. Temperature, pressure, fuel mixture, and timing all have to align within extremely tight tolerances for compression ignition to work correctly. When everything is perfect, it's brilliant. But engines age, sensors drift, carbon builds up, tolerances change. As miles accumulate, maintaining the precise conditions for SPCCI becomes increasingly difficult. The system cycles between combustion modes more erratically, fuel economy decreases, rough combustion events increase, and when something goes wrong with an e-Skyactiv X engine, the diagnostic complexity is significantly higher than a conventional Skyactiv G. Not every mechanic can properly diagnose SPCCI-related issues. Specialized equipment is required. Repair costs are higher. What to do? Follow the maintenance schedule religiously. Use only top-tier certified fuel. Carbon deposits are the enemy of SPCCI precision. Apply the $0 carbon cleaning technique monthly. Change oil at 5,000 miles without exception. And be aware that as the engine ages, the complexity of potential repairs increases significantly compared to a conventional engine. Feature number 2, the Commander rotary dial. Mazda was right to question touchscreen safety. Operating touchscreens while driving is dangerously distracting. Mazda's solution, the Commander rotary dial on the center console, keeps your eyes on the road and hands near the gear lever. In principle, it's the right idea, and for driver safety, it genuinely works. But there are reliability concerns that have cost owners significant money. The dirt and debris problem. The Commander dial sits in the center console exposed to everything. Coffee spills, food crumbs, dust accumulation, hand lotion residue. Over time, debris infiltrates the mechanism. The result? A dial that becomes sticky, inconsistent, or completely unresponsive. Replacing the Commander dial assembly costs $400 to $800. The connection issues. Vibration over thousands of miles can loosen the dial's connection to the infotainment system. When the connection becomes intermittent, the infotainment system freezes, reboots randomly, or becomes unresponsive. Diagnosis is time-consuming because symptoms mimic software issues rather than hardware failure. This means unnecessary diagnostic hours billed to you while the mechanic chases a ghost. What to do? Keep the commander dial clean. Use a dry cloth regularly to remove debris around and beneath the dial. Never eat or drink near the console area. If the dial starts feeling sticky or inconsistent, have it inspected before the problem worsens into full replacement territory. Feature number 3. Active grille shutters. Several Mazda models from 2016 onwards include active grille shutters behind the front fascia. These electronically controlled flaps open and close to manage airflow to the radiator. At highway speeds, they close to reduce drag and improve fuel economy. At low speeds or under thermal load, they open for cooling. Smart system in theory, but exposed to the harshest environment on the car, behind the front bumper. The failure modes. Road debris strikes the plastic actuator arms, bending or breaking them. Ice and snow in cold climates prevent shutters from opening or closing. The electric actuator motor fails, leaving shutters stuck in one position. When shutters fail closed, your engine overheats because the radiator isn't receiving adequate airflow. When shutters fail open, your check engine light comes on and you're making an unplanned dealer visit. Active grille shutter replacement costs $300 to $700. What to do? In winter climates, check behind the front grille for ice accumulation periodically. After any front-end impact or road debris strike, have the shutter mechanism inspected. Check engine code P0491 or related airflow codes often indicate shutter failure. Before we continue, if you want the complete guide to preventing these reliability issues and maintaining your Mazda for maximum longevity, click the link in the description to download your 500,000-mile car maintenance blueprint. It covers known failure points and the maintenance procedures that prevent them. Let's keep going. Feature number 4. e-Loop regenerative braking. The e-Loop system on certain Mazda 6 and older CX-5 models uses regenerative braking to capture energy through a capacitor rather than a conventional alternator. The fuel economy benefit is real, up to 10% improvement in city driving, but the complexity introduces failure points conventional systems don't have. The capacitor degradation problem. The capacitor degrades gradually over time. Unlike a battery that fails relatively suddenly, capacitor degradation is slow and invisible. Most owners don't notice until the efficiency benefit has completely disappeared. When the capacitor needs replacement, you're looking at $600 to $1,200 for the part alone. The integration complexity. The e-Loop system integrates with the alternator, battery management, and electrical load management. When any component develops issues, the diagnostic complexity is significantly higher than a conventional charging system. What would be a $200 alternator diagnosis on a normal car becomes a multi-system electrical investigation. The independent mechanic problem. Many independent mechanics are unfamiliar with e-Loop. When the system develops issues, you're often forced to go to the dealer where labor rates are higher. What to do? Have the system checked during your annual inspection. Monitor fuel economy closely. Gradual decline without other explanation can indicate e-Loop degradation. Budget for capacitor replacement around 100,000 to 150,000 miles. If you're enjoying this video, give it a thumbs up and subscribe to my channel. This helps me bring you more honest car advice for my Mazda guys. Feature number 5. Early MZD Connect infotainment. The first and second generation MZD Connect infotainment system found in 2014 to 2020 Mazdas generated more owner frustration than anything else Mazda has produced recently. The chronic slow performance. Early MZD Connect systems used processors already underpowered for the software demands placed on them. As owners updated software and connected smartphones with increasingly demanding apps, performance degraded. By 50,000 miles, many owners experienced infotainment that took 45 seconds to boot, froze multiple times per drive, and responded to inputs with several seconds of delay. The SD card failure problem. MZD Connect stores its operating system on an SD card. This consumer-grade component operates in a harsh automotive environment. Heat cycling, vibration, and constant read/write operations cause SD card failure. When it fails, your infotainment becomes completely non-functional. A dealer-sourced replacement costs $150 to $400. The update regression. Software updates intended to add features sometimes remove functionality or broke existing features. Owners updated their system and found Bluetooth connectivity worse than before, or Apple CarPlay stopped working consistently. Research updates thoroughly before applying them. What Mazda calls an improvement isn't always experienced that way by owners. What to do? Don't automatically update software just because an update is available. Research whether the update improves or degrades your specific functions before applying it. Clean the SD card slot contacts periodically with electronic contact cleaner. Feature number 6. First-generation turbocharged Skyactiv engines. The turbocharged 2.5-liter Skyactiv G in its first 2 years across different models showed a consistent pattern. High oil consumption, turbo bearing wear earlier than expected, accelerated carbon buildup. The oil return drain angle. On first-generation turbocharged Skyactiv engines, the turbocharger oil return drain had a less optimal angle. Under certain operating conditions, oil drained too slowly from the bearing housing. Oil sitting in a hot bearing housing cooks into carbon deposits that restrict oil flow and accelerate bearing wear. This problem compounds over time. More deposits means slower drainage. Slower drainage means more deposits. The heat soak problem. After engine shutdown, heat soaks into the turbocharger bearing area without oil circulation to carry it away. This coking of oil in the bearing housing is a well-documented cause of premature turbo failure. What to do? After every hard drive, idle for 60 seconds before shutting the engine off. This allows cooler oil to circulate through the turbo and carry away heat. Never shut off a turbocharged Mazda immediately after hard acceleration. Change oil every 4,000 miles in turbocharged models, not 5,000, not 7,500, 4,000 miles. Turbos are the hardest working component in your engine and need fresh oil more frequently. Feature number 7. Retractable door handles. Here's a feature arriving on newer Mazda models that looks incredible and introduces unnecessary reliability risk. Flush or retractable door handles. Stunning design, improved aerodynamics, and a reliability problem waiting to happen. The mechanism complexity. Traditional door handles have been refined over 70 years of automotive engineering. They're simple, robust, and rarely fail. Retractable electronic handles add electric motors, position sensors, return springs, and electronic controllers to what was previously a purely mechanical system. More components means more failure points. It's that simple. The weather vulnerability. Retractable handles are vulnerable to ice in cold climates. Ice forms in the mechanism, preventing retraction or extension. Owners have broken the mechanism attempting to force frozen handles. Repair costs: $400 to $800 per door. The electrical failure mode. When the electronic control fails, you can be locked out of your own car. Some failure modes prevent the handle from extending at all. Imagine being unable to enter your vehicle in a parking lot because an electric motor in a door handle has failed. Not an exaggeration. This is already happening on early adopter vehicles from other brands with the same technology. What to do? In winter climates, park in a garage when possible. If handles feel stiff or slow to respond, address it immediately before complete failure. Budget for this as an increasingly common repair category as these vehicles age. Feature number 8. G-vectoring control. G-vectoring control, or GVC, is one of Mazda's most interesting handling innovations. By minutely reducing engine torque during cornering, GVC shifts weight forward to increase front grip, then restores torque to stabilize on corner exit. The handling benefit is genuine. GVC is one reason Mazdas feel so naturally composed through corners. But the system creates subtle long-term drivetrain stress worth knowing about: the accumulated micro-interventions. GVC creates thousands of tiny torque weight interruptions through normal driving. Every corner, every lane change, every curve. Over 200,000 miles, those micro-interventions accumulate different wear patterns on transmission mounts, drive shafts, and CV joints compared to non-GVC vehicles. It's not catastrophic wear, but it's measurably different from what these components experience without GVC. Not a reason to avoid it. GVC is not a reason to avoid Mazda or disable the system. The handling benefits are real and meaningful for daily driving safety. But if you're planning to keep a GVC-equipped Mazda to 200,000 miles or beyond, inspect CV boots, transmission mounts, and drive shaft components more frequently. Every 30,000 miles rather than every 60,000 miles for these specific components. What to do? Maintain transmission fluid at strict 60,000 mile intervals. Inspect CV boots at every oil change. At 100,000 miles, proactively replace transmission and engine mounts rather than waiting for failure symptoms. And if you want the complete guide to preventing these and every other Mazda reliability issue, don't forget to grab your 500,000 mile car maintenance blueprint from the link in the description. It covers every known failure point and the procedures that keep your Mazda running perfectly for decades. The bottom line: Mazda makes excellent cars. That hasn't changed, but excellent cars can still have features that introduce unnecessary complexity or reliability concerns. The e-Skyactiv X combustion system demands meticulous maintenance. The commander dial needs protection from debris and spills. Active grille shutters need monitoring in harsh climates. IE-loop requires budgeting for capacitor replacement. Early MZ deconnect benefits from careful software management. First-generation turbo engines need shorter oil intervals and proper cool-down procedures. Retractable door handles need protection from extreme cold. GVC-equipped vehicles need more frequent drivetrain inspection. None of these are reasons to avoid Mazda, but all of them are reasons to be an informed owner. Know your car's specific features, understand their failure modes, maintain them proactively. That's the difference between a Mazda that lasts 300,000 miles and one that becomes an expensive disappointment. Your Mazda is capable of incredible longevity. Now you know exactly what to watch for to protect it. If you found these tips helpful, be sure to watch this next video as we're sharing insider tips to help you cut repair costs and keep your car running like new.